Have you ever dropped a glass on the floor? Well, of course you have. We all know exactly what happens. The glass falls first, and then it shatters. It's a very simple rule we live our entire lives by. Cause happens first, effect happens second. But what if I told you that at the fundamental, foundational level of our reality, the universe doesn't actually play by those rules? Today in this explainer, we are diving into a recent, genuinely mind-blowing scientific breakthrough. We're looking at real lab experiments that literally bend the fundamental arrow of time. You see, we naturally assume the arrow of time only points forward, right? It's completely baked into our everyday experience of the world. But I want you to step outside of that for a second and imagine a quantum reality where the sequence of events is not predetermined. A reality where event A can cause event B, while at the exact same fraction of a second, event B causes event A. They exist in what scientists call a superposition of possibilities. Now, I know that sounds like a plot from a science fiction movie, but it's not. This is a highly active, heavily researched frontier in quantum foundations that physicists are testing in the lab right now. So let's break this down simply. The crucial point here is the stark contrast between our everyday classical physics and quantum mechanics. In classical physics, causality is a strict one-way street. A always precedes B. But quantum mechanics allows for something called Indefinite Causal Order, or ICO for short. In this framework, events don't just happen neatly one after the other. Instead, they can actually exist in a blur of multiple timelines all at once. The actual order of operations itself is put into a quantum superposition. But here was the massive scientific roadblock that researchers were hitting. How do we mathematically prove this phenomenon is actually real? For years, early experiments strongly suggested this indefinite order was happening, but they had a huge flaw. They relied on trusting the very measurement devices being used in the lab. So the big overarching question became, how do we prove this without our own measurement tools secretly tricking us with a hidden classical timeline? The physics community needed what they call a device-independent proof, basically an airtight way to certify this mind-bending reality based solely on the raw statistical data, totally regardless of how the lab equipment operates behind the scenes. To crack this case, scientists relied on a truly brilliant setup known as the quantum switch. Think of it kind of like a train station master. Normally, a station master sends a train down track A and then later down track B. Pretty straightforward. But the quantum switch does something incredible. It sends a quantum particle, in this case a photon, down both tracks in two entirely different sequences simultaneously. The order of these operations is coherently controlled by another quantum state, completely scrambling our classical everyday concept of before and after. Let's visualize this. Imagine a ridiculously fast messenger pigeon carrying a letter between two people. Let's call them Alice 1 and Alice 2. Classically, the pigeon has to visit Alice 1, pick up a letter, and then fly over to Alice 2. But what if the pigeon visits both of them first? In this actual experiment, our pigeon is a photon, and that photon is placed in a superposition of both possible travel orders. So Alice 1 sends a message to Alice 2, while Alice 2 simultaneously sends a message to Alice 1. It's happening in both directions at once. Now, to prove this wasn't just some weird glitch or a trick of the light, researchers had to set up a remarkably rigorous test called the VBC protocol. Here's how it works in simple terms. While two stations act on a light particle in this blurred timeline, two completely different stations measure a separate linked particle. And crucially, these measuring stations are physically placed so far apart that no secret signal, not even one traveling at the speed of light, could possibly cross between them to cheat the test. This specific setup mathematically guarantees that there is no hidden classical timeline pulling the strings behind the scenes. Okay, let's look at the actual raw data from the lab, because this is where the theory becomes reality. When the scientists finally ran this protocol, they mapped out the probability distributions of the measurement outcomes. If you look here, the hollow bars represent what quantum theory predicted would happen. And those solid blue bars, that's the actual real-world experimental data. As you can see, it is a virtually perfect match. This specific data decisively shatters the mathematical limits of what is possible if the universe strictly followed classical causality. And the results were absolutely mathematically mind-blowing. Let me put this into perspective. For a system to be proven to follow a definite, boring classical timeline, the results of this specific mathematical test cannot exceed a value of 1.75. Well, the experimental results smashed right through that limit, exceeding the bounds by up to 24 standard deviations. Now, in the science world, getting 5 standard deviations is usually enough to claim a major discovery.
24? That means the chances of this being a random error are practically zero. It is an absolute mathematical slam dunk that indefinite causal order is a physical reality.
Now, in the spirit of rigorous scientific honesty, the researchers do note that there are still a few minor experimental loopholes left to close to make this one 100% foolproof, which is exactly what happened in the early days of testing quantum entanglement too. But make no mistake, this is a monumental leap forward. It conclusively rules out any hidden classical timeline explaining the data. Nature truly demonstrably allows for correlations that do not respect our traditional everyday understanding of cause and effect.
So what does this actually mean for us? Why does it matter? Well, it completely shifts our paradigm. Causality is no longer just a strict, invisible background rule of the universe. It is literally a physical resource that we can harvest. For quantum computing, this is huge. Instead of solving complex problems step by step in a rigid order, computers can use this flexible time as a massive shortcut, solving puzzles exponentially faster than standard physics allows. It even opens up incredible future applications in thermodynamics and reducing noise in quantum communication systems. I think physicist Carla Richter from the University of Vienna hit the nail on the head when she stated that we are now entering an era where the very order of events can be manipulated and utilized as a fundamental tool. Just think about that for a second. In the exact same way that quantum entanglement went from being a spooky theory to a technology that is revolutionizing our world today, grabbing hold of time's sequence, this indefendable causal order, is poised to be the next great resource for human technology.
And this brings us to a profound, strictly scientific question for you to ponder. If cause and effect are truly this fluid at the fundamental level of photons and particles, if they can genuinely exist in a superposition of before and after, how much of our everyday reality is just a localized illusion? Is our forward march of time simply an emergent property, a side effect of being large, macroscopic beings, while the actual underlying machinery of the universe operates completely free from a strict timeline? So as we wrap up this explainer and you go about the rest of your day, a day where you will undoubtedly experience one event strictly following another, take away this one thought. The fabric of reality and our very existence within it is far more flexible, mind-bending, and awe-inspiring than our classical human senses could ever perceive. The end of strict cause and effect isn't the breaking of physics. It might just be the beginning of a whole new understanding of our universe.